We want to prove that the square of an odd positive integer is an odd number. Let's try some examples. 1 squared we know is 1, and 1 is odd. 3 squared is 9, which is an odd number. 5 squared is 25, and this is also odd. However, we can't go on checking forever. 7 squared, 9 squared, 11 squared, and so on. So if we want to prove this for all odd positive integers, we're going to need to use algebra. Consider n to be a positive integer. 2n would be part of the 2 times table and would therefore be even. Remember that numbers alternate even odd, even odd. So if we add 1 to an even number, we get an odd number. So let's square this odd number. We need to expand 2n plus 1 to n plus 1, and you can use any method to do this. 2n times 2n is 4n squared. 1 times 1 is 1, plus 2n, plus another 2n. So this is 4n squared plus 4n plus 1. If we then look at the first 2 terms, take out 2, and in the bracket we have 2n squared plus 2n, and then we have the plus 1 at the end. We know that n is a positive integer. Therefore 2n squared plus 2n is also an integer. If we multiply any integer by 2, we're going to get an even number. Remember, it's in the 2 times table, so it's even. And then adding 1 to an even number gives us an odd number.